Alright, so the last part of our lecture series for the work energy power unit is about power. And power is generally work divided by time. So you want to write out the word work because the unit for power is a watt. So do you see how you could get work and watt mixed up? But remember that work is also the change in energy. So it's also energy divided by time. Now, this is your energy is in joules and your time is in seconds. So a watt is a joule per second. So we just rename it a watt. But it's important to know actually that it's a joule per second. Now, oftentimes when we talk about energy and power, we talk about this unit called a kilowatt hour. Now, okay, remember how power is the energy divided by the time. So energy is power times time, just isolating energy instead. Kilowatt is your power unit. Hour is your time unit. So a kilowatt hour is a unit of energy. Okay? And when you're charged for your electricity at home, you're charged in terms of dollars per kilowatt hour. So this is an important energy term to know. So whenever we're working with, how much does it cost? Your power needs to be in kilowatts, and your time needs to be converted to hours so that you end up with a kilowatt hour. So that's just a little thing to remember unit-wise on how to do things. Some examples. So here's one example. How long will it take to lift a 100 kilogram mass a distance of 25 meters with a 1.5 kilowatt motor? Okay, so nobody said anything about how much is it going to cost or anything like that, so you're not going to be using kilowatt hours. But you are going to be using power equals either your work divided by your time or your change in energy divided by time. And I'm going to solve this both ways because it can be done both ways. So you've got your little mass and you're going to lift it up 25 meters. And it's a 100 kilogram mass. Okay, so what force are you lifting up against? You're lifting up against gravity. Okay, so you have to find the weight of the object, which is 100 times 9.8, so it's 980 newtons. Okay, so work-wise, it would be your force times your distance. So your work would be 980 times the 25 meters, which comes out to 24,500 joules. Okay, so that's if we were going to do it with work, but we could also do it with our energy. Because what kind of energy, if it's going from here to here, what kind of energy is it getting? Yeah, it's getting gravitational potential energy. What's the equation for gravitational potential energy? mgh. And so what do you have to do? Take your mass, 100 times 9.8, times your height, which is 25. Oh, look, that's the same math we just did. 24,500 joules. So see, either way, force times distance or change in energy, it works out the same way. So now for the rest of the problem. We have that power is equal to, let's just do our energy divided by time because I really like energy more than work. Okay, we have 1.5 kilowatts, so that's 1,500 watts. In this equation, we need to have our standard units, and so we need to make sure we standardize our units. So 1,500 equals our energy, 24,500, divided by our time. And solving for time, we get 16.3 seconds. Which isn't bad. That's not that bad. So that's one kind of type of problem. And notice you can do it both with work and with energy. And you really need to get into the habit of work causes a change in energy, because a lot of times these are easier to solve with energy rather than with forces. Okay, here's one that's relevant for a lot of us. Okay, how long will it cost to run our 1,000-watt hair dryer for 15 minutes? It's about how long it takes to dry your hair every day. So if you washed your hair every day and blow dried it every day for a month, if the cost of electricity is 12 cents per kilowatt hour, and that's the approximate cost of electricity here. So we need to find out, basically, it's 12 cents per kilowatt hour, so we need to find out how many kilowatt hours we have. So we have 1,000 watts. We need to change that to kilowatts. So 1,000 watts is 1 kilowatt. See, nice easy number. For 15, and then we need to find our time, how long we're doing it, because we remember we need kilowatt hours. So we have 15 minutes every day for a month. So let's say there's 30 days in a month, but that's minutes. So let's change that to hours. 15 minutes is a quarter of an hour, so 0.25 hours times 30 days in a month. Okay? So that gives us how many hours we ran it. So we ran it for 7.5 hours the whole time. So the total number of kilowatt hours we used is our kilowatts, 1 kilowatt, times the 7.5 hours. So we used 7.5 kilowatt hours of energy, because kilowatt hours is an energy unit for the month. And then how much does it cost? It costs 12 cents for 1 kilowatt hour. So altogether, that's going to be 90 cents. You cost your parents 90 cents by blow drying your hair every day for 15 minutes, which that's not that bad, but you know, you put it on top of all the other things that you do, maybe it is a lot. I don't know. So are you willing to pay 90 cents a day? So those are kind of the types of problems that you're going to be doing. So you're either going to be doing energy divided by time with regular power, or you're going to be finding cost and kilowatt hour type problems. All right? So that should be easy enough. We'll see you later. Bye.